So as we've seen before, it is possible to add two sequences or two strings. It is also possible to multiply a string by some integer. So if we want our class to use operators such as these and on other special operators, then we have to use operator overloading. For example, it would be useful if we defined an operator for adding two complex numbers, like while using our class right here. This would also allow us to control instance variables without writing getters and setters. So let's dive right into our example. So I'm gonna use operator overloading for addition, or the plus symbol, plus operator. So in order for me to add two complex numbers. So in order to do that, I'm going to define a couple methods right here, and I'll explain what they are in a second. So we're going to have def 2 underscore string 2 underscores. We're going to have self, and then we're going to have, just self, the self attribute. So what this is going to do, it's going to display a string of our result, and I'll explain more in details just in a sec. Let me just write it out. Return string. We're going to return a string of, so we're going to convert our real part of the number to a string, and then we're going to concatenate it. So plus with a plus to make the complex number form properly. We don't need spaces in there. We're going to concatenate it. Now we're going to concatenate. Excuse me. We're going to concatenate it now with the imaginary part converted to a string. So we have get image, and then we're gonna add now with an I at the end. I. All right, that's that part. And now here's our overloading. Here's the part where that operator overloading comes in. So we're gonna make a method add for addition. So it's gonna have self and other. It's going to add two complex numbers together. So what we want to have, we're going to return a complex number which consists of self. The real part is going to consist of one get real plus the other get real. It's the other real number part plus the other real part. And then we're going to add the imaginary parts together. Let me just check. Self get imag plus other get image. Let me just check that. Oops, there's a syntax error. See, I just like to check. Line 37. Oh, I forgot the colon. Everything checks out. Yep. All right. So now with these, we can add them up. We can add these two complex numbers I made right here. So we're going to print, and we're going to print A plus B. And that checks out, right? Here's our result. So in this example, we overloaded with the plus operator. That is, we define the addition of two complex numbers using this method right here. We should also mention the term method overriding. In our example, that's this method right here for the string. You might say the operator overloading works on the overriding principles, which is closely related to the concepts of inheritance, because overriding means changing the implementation of a method which is given by one of the method's ancestors. So we basically used the values getReal and getImage to display a string of our result. And through overriding, a class can copy some other class and modify it if required. So this method use these as needed and as required and obtain the string. We'll talk about this a bit more when we get to the inheritance topic. But for now, in our example, we used overriding to print out the complex numbers in the complex number in a specified format without calling getters and setters. As you can see, we just returned a string. Now, let's get back to the main topic. So, other than the addition operator, which is a binary operator, we can also overload a wide variety of both unary and binary operators. And unlike binary operators, unary operators are performed on one operand only. So in our next version of our complex class, we will define some other operators. So let's see what we can do. We're going to make ones for multiplication and division. So we're going to override, here we go, overload, excuse me. For def, we're going to make a method for multiplication. And we're going to have self attributes and self and other as our arguments. So now in these two following methods, we're going to check if this value right here is a normal number or if it's a complex number. So if the type of other is in int or float, meaning if it's a float, or int if it's a floating point number, or integer, we're going to say return. We're going to return a complex number where the real part is multiplied by this number, other, and the imaginary part is also divided by this number, other. Self get imag, there we go, times other. So, but what in the other case, this other case assumes that the number will be complex. So we're going to return a complex number, which consists of, let's see, here we go, self.getReal times other other.getReal, my bad, other.getReal, and then we're going to have minus the self.imag times other.getImag. That's for the real part. And for the imaginary part, we're going to have self.getImag times other.getImag plus self.getReal times other.getReal. Everything checks out with that. So now we can actually do multiplication. So let's do that right now. So we're going to print a new complex number. It's going to be A times B. Whoops. A times B. And there's our answer for that. We can also we don't have to have another complex number. We can also just use a number like 2, and it works. So that's multiplication. And now let's move on to our division overloading operator. So let me just see, escape that. Let's see right here. So this one's a little more complicated, but you'll have, bear with me. So in older versions of Python, overloading with division is done like this with just div. However, I'm running Python 3.5, so I have to use TrueDiv. So be sure to use TrueDiv and not just div when working in Python version 3. All right, so let's get this underway. So self and other. So in this one, we're also checking if it's a regular number, or if this other argument is a regular number or a complex number. So we're going to do type if type of other is an integer or a float. We are going to just do the following. We're going to return a complex number that is the following. So self get real is divided by the typecasted float of other in case it's integer, because when doing division, remember you should use float because there might be a decimal number. It might be a decimal number and not an integer. And the imaginary part is going to be self.getImag divided by float, same thing as before, float of typecasted, other typecasted to float. All right, so let's just test that. Yep, everything checks out. All right, now let's go on to the next part. So we're gonna have the else statement now, and this is where we assume that it's a complex number is being, this argument is a complex number. So here we go. So we're gonna set a couple variables set to equal to some parts of the complex numbers to make things more simple for us. So we're gonna have A, B, C, and D respectively equal to the following. So self get real, comma self dot get image, comma other dot get real, comma other dot get image. Since we're dealing with division of complex numbers, we have to set a nominator. So nominator is going to be equal to the following. We're going to have C times C plus D times D. And now with everything set up, we can return the following. So we're going to return a complex number, which is the following. So we have A times C, not capital C, A times C plus, let's see, B times D. And then outside that, we're going to divide it by a nominator. That's our real part. And then comma, the imaginary part is going to be the following. It's going to be B times C minus A times D. Let's space that out. There we go. And divided by nominator. Let's check invalid syntax, just checking my mistakes right here. Oops, I forgot a parentheses. Wait, no. Wait, something's missing. Let me just check. Complex. Maybe there needs another one. Nope. So I opened one. Oh, here we go. There we go. Just always remember to always check your parentheses. Yep. There we go. So now that all checks out. And now let's see how this division works. So let's do A divided by B now. Oops, spacing is weird. A divided by B. And that worked out. And now let's do, instead of using a complex number, let's do, for example, B divided by 2. And that checks out. So now we've defined two more operators in operator overloading. And so with this, we conclude this tutorial.